So more multiplication with exponents. So yesterday, as we talked about, like if we deal with x to the 3 halves, it's really like x to the 1 half to the 3rd, because you have 3 radical x's, because x to the 1 half is really radical x, and then you have 3 of those. That is going to guide us with taking a power to a power, which really all you have to do is multiply them together. Because, like for example, if you have m cubed to the 5th, you really have m times m times m 5 times. So then if you write out all of those, you're going to end up with 15 total m's, which is why we get m to the 15th. Same sort of thing with the rational examples like I just showed you, except we get even harder. We say, what about radical x, or x to the 1 half, to another radical power? So like to the 3/5. So we can combine those and end up getting x to the 3/10, and then go from there. Questions? Then if we have a product to a power, this is what throws some people off. You want to distribute the power to all terms. I was going to say both, but you can have more than 2, to all terms in the parentheses. So this is really going to take my 4th power to the 3 and my 4th power to the x. I can evaluate 3 to the 4th is 81. X to the 4th I cannot simplify, so it just stays x to the 4th. Questions? Cool. Buenos. So what is the simplified form of n to the 4th to the 7th? Let's go cards today. I'm tired of picking people.
Dude.
Greg!
I'm new though.
You're new?
Yeah.
What do you mean you're new?
It's like the first time I raised my hand in a week.
I'll come to you.
Yeah, it's
Like
the
for
second
B.
day in a week.
Don't you just like multiply that?
Yeah, so what do you get?
N to the 28th.
Yeah, n to the 28th. You just multiply them. Just underlining it, emphasizing it. Or it could really be over 1, because it really is, if you want to talk about all powers being rational. But that over 1 means that the n is taken to the first root, which is really nothing. It does nothing to it. So, because the radical symbol really has a 2 here. If you don't put anything in there, it really has a 2. B, Mr. Carpenter, will come to you.
Yay.
What do you do with those 2 rational powers?
Get a calculator and
No, you don't. I agree with part 2 of what you said, though.
you multiply them together.
Yeah, you can do 2/3 times 1/2 without a calculator, because how do you multiply? Grant? How do you multiply fractions? Straight through,
Flip
right?
one, divide.
That's if it starts with division. We like multiplication because multiplication goes straight through the top and then straight through the bottom. So what's 2 times 1?
Okay.
3 times 2?
Everywhere too.
Or
1 to the 3rd.
we could have cross-canceled this 2 and that 2 and just gotten the 1 over the 3. So it's really just x to the 1/3 or cube root of x. Class,
Yeah.
p to the 5th to the 4th is p to the 20th.
I said it first.
Biggest mistake I'll see is people accidentally adding them instead of multiplying. Did anyone talk to Evan?
I did.
Yeah, what did he say?
He said, I saw him like putting up Christmas lights.
Hey, they're not lit yet.
Wait,
It was good weather.
Wait, he saw
Well,
They
we like to
won't-
put Christmas lights on your back.
They won't be lit until Thanksgiving. Post Thanksgiving, really. But so Evan was driving by my house, like if you can imagine like the passenger seat in a car. So he's coming down the street and he probably didn't know where I live. He was just looking out the window and he like and he just like watched me the whole and I saw him and I'm sitting up on the roof and I was like my roof because I had my harness on. I was roped up, and if I fell, I would not die. I like my life too much. But it was just really funny because Chelsea, my wife, was on the ground. Like, you know, in case I fall, call 911 or whatever. And she was like, "Who are you waving at?" I'm like, "One of my students." She's like, "You're so weird." Huh?
But he's not your student.
He was.
So?
Once my student, always my student.
Some people say I'm not cute.
So, Mr. Hudson,
I mean, that's obvious.
Oh yeah. Yeah. Yeah.
Mr. Hudson, you
All right.
from Grant's worst nightmare.
What? That teachers actually live like near you guys?
Well, I know
Mr.
where you
Roman,
live.
like,
Mrs. Rosie,
not
my
even
neighbor.
3 minutes away from me.
Mr.
Mr.
Roman
Rosie,
lives right next to my neighborhood park.
So. Oh my gosh, we exist outside of school.
Really? I thought like as soon as you stepped
Try
out,
this.
like disappeared.
Here's the thing. Here's where this gets tricky. The y to the third does nothing until we evaluate the y to the 5 halves to the -2. Now when we look at y to the 5 halves to the -2, those are really going to multiply. And since it's 2 on top, 2 on bottom, really I can get rid of the 2's, and that just becomes y to the -5th. Now what does y to the -5th really tell me to do, Ben?
Wait, wouldn't you add y to the third to y to the -5th?
I agree, because this y to the third still needs to happen. I don't know why this link thing keeps popping up. I'm just going to close this. Oh, there's Matt.
my map.
Someone in 7th grade.
So now we have y to the third times y to the -5th. Yes, I just add them, but then that gives me y to the...
-2nd.
Now what if I asked you to express this using positive exponents? Grant?
You put the y under 1.
Ah, we
1
flip
over
it.
y, and then the y is now to the positive 6.
Yeah, and my power stays on it, but it becomes positive. So my answer would either be y to the -2 or 1 over y squared.
Ooh, I'm right. Which one's the easiest to work with?
It depends what you're doing. If you're dealing with like real situations and real values, I like this. Because really that would then be 1 over radical y. So then if you know like, oh, y is 4, then you get 1/2 here. You know what I mean? Because radical 4 would be 2. So that would make it a little easier as opposed to saying, well, 4 to the negative power of 2. It's just kind of harder to think about. Try this. What is your final using positive exponents?
I've got it home.
McKenna, what's the first thing that you're doing here?
Multiplying the exponents for the second x.
Yeah, multiplying the exponents of the second x. So that x squared stayed the same. That gives me x to the
-24.
-24. Thank you very much. Gone and gone. Robert, what do I do next?
Then you multiply those.
Then I... What?
Well, it says multiply. You have to multiply, but then you just add them.
Ah, so I'm multiplying the values, but adding the exponents. So that's x to the
-22nd.
-22nd.
Equals.
So then, Alex, that becomes 1 over x to the 22nd. Hey guys, I gotta correct myself. I just realized this. I'm surprised nobody else did. This up here is wrong
I didn't know what that was.
because it's actually y squared, so it would not become radical y. It would just stay y squared. So like when I give the example, if y was 4, then it'd be 1/16, not 1/2. My apologies. I had a brain fart.
Like that.
All of that is bad.
Mr. Hudson, just record that second screen.
It's okay.
No. So I might want to drag. So I had that mistake. This on the last slide does not become radical x. It's just y squared. And we do have guys absent today, so hopefully they utilize the video.
We do?
Yeah, Kale and Seth.
You do
The mighty
You
duo.
want to capture that, Mr. Hudson.
They never said anything.
You should probably factor. Just maybe. No, because like seriously.
So then, if we have to simplify these things, let's get our situation pulled up here.
In this problem,
Stop. So, we want to talk about the area of the square. How do I find area of a square? Emily? We just square the side length. So I know that my side length is 5x cubed. And then I square that. Now this is where that distribution comes into play. My squared is going to apply to the x squared, and it's going to apply to the 5. So this becomes 5 squared, x cubed squared. 5 squared is really
25.
x cubed squared is really x to the 6th.
I didn't do that.
What'd you do, Greg? Just do it
I just did
immediately?
5x to the third power times 5x to the third power.
And then you just group like terms?
Yeah,
Yeah. You can do that as well.
it was easier.
Easy's relative. It's what your brain likes.
I think this
I'm really trying to eradicate, like get rid of the word easy being used here, because easy doesn't actually exist. It's a thought. It's what your brain likes. Not like I keep telling them easy's a relative word. Easy is not. You can't define something as easy.
We should show this
Wait, so you can't do like
No, not right now.
I think these ones are less difficult, but the like actual word problems, it's like more confusing.
Yeah, let's get one of those.
What?
But these ones are fine.
I think there's one in the next part.
Yeah, it's fine.
So, Ben, what do you do first?
You distribute the
Yeah.
to the 7, which is 6
Yeah, so it's 7 to the 3rd, and then m to the 9th to the 3rd, which really you could just go ahead and write that they're going to multiply.
Yeah.
7 to the 3rd?
346. M to the 27.
Yep. Now, Greg, here's the reason that we don't normally write out the repeated multiplication. We would rather distribute. Here you'd have 7m to the 9th times 7m to the 9th times 7m to the 9th, already getting a little long. What if that power was like the 5th or 6th or 7th? Or like, then you're going to have a lot to write out. So just make sure you understand both methods.
Chill, whoever did that.
So now we have the product of two different variables, all with their own independent powers. Jacob, what's the first thing that you want to do here?
So you distribute the 10, the power of 10 to the n to the power of 1/2, and then what you get is n to the 5th.
N to the 5th. Then
Multiplied, and then you distribute the 3 to the entire, all 3, thingy-mabobbies. And then
thingy-mabobbies.
4 cubed.
That's some beautiful
4 cubed. So I'm
wording.
getting some feedback, so I'm going to turn that off real quick. 4 cubed times m cubed, because m was just the power of 1,
times n to the negative
times n to the negative 2, because the 3 on top and bottom would cancel each other out when I do that multiplication. Then, you going to take us home, or you going to pass it off?
So then you add the 5 and the negative 2 because they're like terms
Got to group like terms, the 5 and the negative 2, so now n becomes
to the 3rd.
to the 3rd,
4 to the 3rd, you simplify that.
which is
64.
64. I'm going to put that out front because we like coefficients to be out front.
Then m to 3.
64, n to the 3rd, m to the 3rd.
Wow, we have 3 cubed. 3 cubed.
I did this.
Cubed.
You could just put it together.
Are you gonna say that
4
again?
times 4 and n
What?
cubed.
Can we go through that again?
Yeah.
So,
Oh, I see what I did wrong. Oh, never mind.
you good then, Leah?
Can you put the n third where the m third is and the n third where the n third is?
Do you want them
Like, can you switch
alphabetically in
them
order?
around?
that's
Can you do that?
Well, can you switch around the order of multiplication?
Yes.
Yes.
Okay.
So multiplication is commutative. Order does not matter. We only write the 64 out front because we like the coefficients to be out front. It's not like more right or anything like that. It's we just like it that way.
Like less confusing to the front, please. Less confusing.
Try this one on your own. He just works ahead.
So you should not do that though, huh?
You can't.
If you like know what you're doing, and especially if it's the got it.
Because you have to get it. I got this.
Grayson Baylor to the office, please.
Anything to the 0 power is 1. Anything to the 0 power is 1.
I got this.
So it's the whole idea of it's not multiplied by itself any times, and because it's 0 power, it doesn't even exist. It comes back to if you had x to the third over x to the third, how many x's do you really have? None, but any number divided by itself is 1.
You can also use the idea of like a geometric sequence. Like if you every time you multiply by 7, when
Yeah,
you get
look
to
up the
0
powers and
sevens,
down the powers.
it's 1.
Yeah. So Wyatt, what do you get here?
I got 81 times y to the 20th.
81 times y to the 20th? That is correct.
Boy.
Wait a minute, what?
Yeah.
So first thing was our 2 distributing gave us that -4. The 3 to the 4th and the x to the 4th stay the same. The 5th to the 4th becomes y to the 20th. The x's with a power of -4 and +4 cancel each other out.
X is just 1.
No, not x is 1. X to the 0 power is 1.
Yeah.
If you say x is 1, you're trying to define the value.
Can x be like anything?
Right,
Yeah.
x is anything still. We don't know what x is. It to the 0 power becomes 1, and then just essentially disappears. And our last section, no, maybe we have 2. Really?
2 more.
Why does that always do that?
Because at this point I've been on for like an hour and a half or so, whatever the timeout amount is.
Not on topic.
Wait, so it just like shuts down if you're on it for too long?
It logs you out automatically. A lot of systems do that just for security, so nobody else can get into your account. The thing I wish it did was realize that I was still actively using it and like not time me out because of that. But it might be set up from this page, which I'm not actively using that page. That page just sits there. Try the next one. You can probably do it.
Oh my gosh.
We had 1 section left to do, of course.
Got it.
So here we go. Scientific notation.
I love this stuff.
The expression 1/2 mv squared gives the kinetic energy in joules. Joules is what we measure energy in. With a mass of m, speed of v. Why do you use v for speed? Velocity.
Boom.
What is the kinetic energy of an experimental unmanned jet with a mass of 1.3 times 10 to the 3rd kilograms? We know it's unmanned because otherwise that's extremely light. Traveling at a speed of about 3.1 times 10 to the 3rd meters per second. A lot of times in physics we use meters per second because the rest of the world uses meters, and talking in seconds makes it more relative than in hours or minutes or anything else like that. So we have to plug in our values. I get it, you have your answer, but let me show some of the work. Or you want to talk through the work and I'll just write it.
Okay. So you just substitute everything in. So 1/2 times the mass, which is 1.3 times 10 to the 3rd times, and then you have to put the other part in parentheses.
Yep.
Times 3.1 times 10 to the 3rd to the 2nd power.
So, nothing really happens with my 1/2 or my 1.3 times 10 to the third, unless I want to combine the 1/2 and the 1.3 times 10 to the third, which I really don't want to yet because I have two numbers in scientific notation. So leave these how they are. What do I do here? Ben?
Distribute the square.
Distribute the square.
So the 3.1 and
3.1 squared is going to give me, is it over 10?
no, it's 9.61.
9.61, I knew it would be close. Times 10 to the sixth now.
I almost said 50.
Now I want to combine my scientific notation values. This is all just multiplication. The parentheses make it look more confusing than it is. It's just 1.3 times 10 to the third times 9.61 times 10 to the sixth. It's a string of multiplication. So I can rearrange it, whether I physically do it or mentally do it. Just take your 1.3 times your 9.61 and your, bless you, 10 to the third times 10 to the sixth. So my terms highlighted in, what?
You forgot to say divide by 2.
Yeah, I'm going to do that last.
Oh.
Or I could do it now with any of these terms if I wanted to, but I'm just going to save it for last. So 1.3 times 9.61. 12, what? 493, that's what I couldn't hear. Times 10 to the 9th, right? Because those powers will add. And we still have half of this. So to half it, we don't need to mess with the 10 to the 9th. We just half the base value, the 12.9 or 493, sorry, and it becomes 6.2465 times 10 to the 9th. Well, I was about to ask, what is our label here? Joules. So, it'd be J.
You were the
J for joules.
Lowercase j?
yes.
I forget. You'd want to ask either Mr. Cabilo or Mrs. Lemire about that because I forget if it's lowercase or
I
capital.
feel like it's supposed to be
I
capital.
think it might be capital.
It's lower.
It's
Yeah,
capital. It's capital, boy. What's that?
Yes, it is.
Yes, it is.
Oh, I wrote a capital F. It's good. It is.
Yeah.
I don't like the letter.
Try this one.
You
Let's
don't
see
like
if
what?
we can get it.
The letter J. Actually, let me check my. You know, like, I don't want to get it wrong. Yeah, hexagons are so
Ooh, you got it, Olivia?
Hudson, do you like hexagons?
They're the best shape ever.
Yes.
Okay, maybe not ever, but they're an extremely beneficial shape.
But octagons.
I like
What about hexagons and octagons?
I like
Actually,
hexagons.
what about
Hexagons.
pentagons and hexagons, like on a soccer ball?
I like
Yeah.
Because pentagons and hexagons perfectly tessellate in 3 dimensions.
I don't like hexagons because they try to trick you into thinking that they're octagons, but they're not.
What? Because they try and trick
Olivia, you looked like you might have an answer. Did you finish computing yet? What'd you get?
11.25
Wait. You can't express it like that.
Now, it would not be times the 10 to the 9th because to put it in scientific notation, we have to take this decimal to the left one. You can't barely see my arrow. So if you have 11.25 times 10 to the 9th, when I move my decimal left, it moves my power up. So that's how I turn this into 1.125 times 10 to the 10th.
Wait a minute, that was number 5, right?
Yeah, part 5 got it. And that's it.
Time to do our homework.
You do. You have a good amount of time. I'm
Wait,
going
throw it
to
up
pause
now.
this because you guys all start talking nonsense.
Oh.